Hi, I'm Zakai.
Hi, I'm Azrin.
Hi, I'm Fat Sarwar.
Hi, I'm Lanisha.
Hi, I'm Mei.
Hi, I am Nazrul.
Hi, I'm Danish.
And hi, I am Shamirul.
We are engineering students.
Hi. Have you ever heard about one separation process, which is solid liquid extraction? By definition, solid liquid extraction is a process of separation which extracting substances from a solid material or matrix using suitable solvents. This process provides a lot of advantages to us which will be discussed in this video. Besides, we will learn on how this process works and how it can be applied in our daily life. Moving on to the next part, the concept of this process is similarly to the liquid-liquid extraction, where one of the solvent is water or an aqueous mixture and the other is a non-polar organic liquid. As in all extracting process, liquid-liquid extraction comprises a step of mixing or contacting, then followed by a step of separation. It is important to consider both steps in the selection of solvent and modes of operation. However, in solid liquid extraction, concept of contacting or mixing is in between the solute and the solid matrix, rather than in a carrier liquid.
Let's continue how the leaching process occurs. Three types of leaching require the process to be done in different types of extractor. The different type of leaching is fixed bed leaching, moving bed leaching, and agitated solid leaching. There are 4 general steps of the overall leaching process. Let's apply these general steps for a fixed bed leaching extractor. Firstly, the solvent is transferred to the solid surface. Then, after the penetration of solvent into the solid, solutes are dissolved, and finally, the solute is penetrated out of the solid and transferred back to the bulk solvent solution and then to the storage tank. For the moving bed leaching, Ballman bucket type extractor is used. Dry flakes of solids are added at the upper right side of a bucket. As the bucket descends, they are leached by a dilute solution of oil in a solvent called Havicella. This liquid percolates downward through the moving bucket and is collected at the bottom as Woolmansella. The buckets moving upward on the left are leached countercurrently by fresh solvent sprayed on the top bucket. The wet flakes are dumped as shown and removed continuously. Hildebrand screw conveyor extractor consists of 3 screw conveyors arranged in a U shape. The solids are charged at the top right, conveyed downward across the bottom, and then the other leg. The solvent flows countercurrently. For agitated solid leaching, fresh solvent enters in the first stage thickener. The clear settled liquid leaves and flows from stage to stage. The fit solids enter the last stage, where they are contacted with solvent from the previous stage and then enter the settler. The slowly rotating rake moves the solids to the bottom discharge. The solids with some liquid are pumped as a slurry to the next tank.
There are 3 types of application which can be related to the solid liquid extraction, which are the daily life, metal processing industry, and pharmaceutical industry. For daily life, the first one is decaffeination of coffee. Most popular methods of decaffeinating coffee are Swiss water processing, ethyl acetate processing, methylene chloride processing, and supercritical carbon dioxide processing. Ethyl acetate occurs naturally in many fruits, which is why this method is often referred to as natural decaffeination. This method decaffeinates the coffee beans by approximately 97%. The steps with using ethyl acetate are as followed. The first one, green coffee is prepared. Next, coffee is steamed for about 30 minutes. Number 3, a low pressure steaming process will open the pores of the coffee. Number 4, coffee is placed in a solution of water and ethyl acetate. Number 5, green coffee is submerged in the solvent. Number 6, once the coffee is saturated, the tank is drained and fresh solution is introduced. 7th, the coffee is removed from the solution and prepped for another steaming. Number 8, the final low pressure steaming removes the remaining traces of ethyl acetate. The last one is decaffeinated coffee is then dried.
Coffee is consumed in large quantities, and coffee brewing is the perfect example of solid liquid extraction in daily life. Why? Because when we pour hot water on the coffee powder, the hot water is acting as the liquid and extracting the coffee flavors from the coffee powder, and the filter mesh or filter paper is separating the solids from the liquid. And tea brewing is another perfect example of solid liquid extraction in daily life. And it is very similar to coffee brewing. Why? Because when we pour hot water on the tea leaves, the hot water is again acting as the liquid and extracting the tea flavors and extract, and the filter paper or filter mesh is keeping the solid leaves separate.
Next, solid liquid extraction is also involved in metal processing industry. One of the applications is using a sodium cyanide solution to leach gold from ore. Cyanide can refer to any of a number of compounds that contain the chemical group CN, one atom of carbon, and one atom of nitrogen. Hence, cyanide can combine easily with metals, so it can be used to separate metals, such as gold, from their ore. There are two types of gold leaching, which are wet leaching and heap leaching. For wet leaching, it can be called as tank leaching. In wet leaching, it includes ore, tank, sodium cyanide solution, and dam. Firstly, the ore is mixed with cyanide solution in large tanks. The mixture is left for a few days. Then the solution is drained out and sent for recovery process. In heap leaching, it includes heap, light pack, sodium cyanide solution, crushed ore, and basin. At first, a giant pressure pack is placed on top of the heaps. Ore is crushed into small chunks and placed on the packs. Cyanide solution is sprayed over on the heaps that fill with crushed ore. The basin collects the new metal implemented solution, which is stripped of gold. Lastly, some leachate is recycled back to the heap until the ore is depleted.
The solution obtained from wet leaching and heap leaching are required to undergo gold recovery process in order to acquire a strip of gold. There are two steps involved in gold recovery process, which are adsorptions and desorptions. Activated carbon is used to achieve gold recovery from pregnant solutions. Approximately 75 cubic meter per hour solutions is pumped through 4 columns in series and discharges into parent pond. Each column is designed to hold 1000 kg of carbon. The next step is desorptions, which is also known as stripping. There are two systems can be considered in desorptions, which are Zadra stripping and ARR stripping. For Zadra system, it has a longer elution time, but simultaneous stripping and electrowinning. We can construct this system in low capital cost, but it's generally less efficient than the ARR system. For ARR system, it has a short elution time, but with various processes like acid washing and cyanide pretreatment. Compared to Zadra system, ARR has higher capacity and efficiency. Both systems produce an electrolyte solutions, which will then undergo electrolysis process to extract gold. The gold recovered onto steel wood cathode. Steel wood is removed and treated to eliminate iron.
Lastly, the application of solid liquid extraction can also be found in pharmaceutical industry, which involves in medicinal and drug extraction. This method is widely used to extract flavors and pharmaceutical ingredients from natural, mainly plant-based material, which are from roots, leaves, and also stems. The common use solvent involved in solid liquid extraction are water and alcohol. Water is one of the most polar solvent and is used in the extraction of a wide range of polar compounds. It is also non-toxic and highly polar. However, water promotes bacterial and mold growth, which may cause hydrolysis. Other than that, alcohol is also one of the most common used solvents. This is because it is polar in nature, miscible with water and non-toxic at low concentration. However, it does not dissolve bad, flammable, and volatile. Also, paraffin or liquefied gases such as carbon dioxide and propane also were used. There are factors to be considered in selecting solvent. Firstly, the boiling temperature has to be low to prevent degradation by heat. Secondly, selectivity, the ability of the chosen solvent to extract the active constituent. Thirdly, safety, the ideal solvent must be non-toxic and non-flammable. Fourth, cost-effective, which are more affordable. Next, recovery, the solvent should be quickly recovered and separated from the extract. Lastly, viscosity should be low to allow ease of penetration. Next, these are some factors that need to be considered in choosing extraction method. First one is stability to heat. Heat-stable plant material is extracted using soft flow extraction or microwave-assisted extraction, whereas non-heat-stable plant materials are extracted using maceration or percolation. Second is nature of solvent. If the solvent of extraction is water, maceration is a suitable method, but for volatile solvent, percolation and soft flow extraction are more appropriate. Third one is the final volume required. Large volume products are prepared by maceration, whereas concentrated products are produced by percolation or soft lead extraction. And lastly is the cost of the drug. Cheap drugs are extracted using maceration, whereas costly drugs are preferably extracted using percolation. Lastly, these are some of the commonly used methods in the extraction of medicinal plants. Firstly is the soft flow extraction. It is suitable for plant material that is partially soluble in the chosen solvent and with insoluble impurities. Second is maceration. It is convenient and very suitable for thermolabile plant material. Third is a microwave-assisted extraction. It is suitable for extraction of flavonoids, And lastly is percolation, where a dried, grinded and finely powdered plant material is moistened with a solvent of extraction in a clean container.
The point of view, solid liquid extraction is very useful in our daily life. As we go through the video, there are some points can be highlighted, which is by learning solid liquid extraction, it will help us in future, especially when we are in industry. Besides, the knowledge on solid liquid extraction will give us a different perspective and different view when it is applied in our daily life. All in all, the separation process is very interesting to learn because this topic is wide and fun since we learn the things that happen in our surrounding. Thank you for watching, and hopefully you guys can help us by like and share our videos. And finally, see you soon. Bye.